try this one. Suppose I have R equals to 30 ohms, inductance equal to 10 henries, and capacitance equal to 2.02 farads. And let's say your external voltage supplied to this LCR circuit is 50 sine 2t volts. These are just units. Okay, how do you solve this system? Solution. Well, the formula is resistance acts like resistance. So in the mx double prime plus cx prime plus kx equal to 0, this mechanical vibrations thingy, just like that. Resistance is just like this thing, capacitance, the friction coefficient, right? So you have plus 30 I prime there, and then L has to do with the change of current, right? So L times the rate of change of the current is the voltage consumption across the inductor, right? So it's really Li prime R times I plus Ri is the voltage consumption across a resistor, right? And 1 over C times Q, that's the voltage consumption across the capacitor, and equal to E. That's actually the master equation for this system, but you have to differentiate this to get an equation for I, because you get I double prime, Ri prime. Then if you differentiate Q, rate of change of the current, the charge is what we call the current, right? Current is, it's a flow of the charge, so it's the rate of change of the current. So it's 1 over C times I equal to E prime. So that's the master equation we have to use. So L goes here, which is 10. And then C, 1 over C goes here. And then I equal to, you have to differentiate this, which is 100 cosine 2t. Okay, so that's the equation we have to solve. And since there is no initial condition provided, it's just asking for the general solution, and most likely you're really looking for the steady periodic solution, which because the complementary solution dies away, right? So the transient solution is not what we're after. We're really after the steady periodic solution. Okay. Now this by the way will never have any duplicates because of this term. The solution of this is never in this term. Okay. The solution of the complementary will never look like this one because this is non-zero. The only time that you're going to see something like that is when this is equal to 0. In that case, we might have some resonance. Yes?
10I double prime?
Oh, thank you. All right, thank you. Therefore, I have, if I divide everything by 10, I get I double prime plus 3I prime plus, let's see, what is this? This is 50. 50 divided by 10 is 5. And then if you divide by 10, it's 10 cosine 2t. That's right? Okay, let's just go for IP for this case. All right, so therefore IP must be what? A times cosine 2t plus B times sine 2t, right? By the method of undetermined coefficients. Now we have to differentiate this twice, because then we have to multiply 1, 3, and 5 and add them up to create the left side. So if I differentiate this, it will be negative 2a sine 2t, and this will be 2b cosine 2t. And then when you differentiate this, you get negative 4b cosine 2t, whereas this one you get negative 4a. Oh, this is sine, sorry. Sine. Oh, what am I doing?
Negative 4b sine. Right?
No.
These are cosine, sorry.
Oh, okay.
And this one is sine. Okay, so, sorry, I'm differentiating this way so that I have the cosine on one side and sine on one side. That way it's easier to keep track of things when you calculate. Okay. All right, so I have 1, 3, so I have to multiply by 3. And for this, I have to multiply by 5. And then I add them up. Let's see what we get. Then I have I double prime plus 3i prime plus 5i equal to, for the cosine, I have 5a minus 4a, which is a, plus 6b, cosine 2t, plus 5b minus 4b, that's b minus 6a, sine 2t. And that has to equal to what? 10 cosine 2t, right? This has to equal to this right side, this right side here. So that means a plus 6b must equal to 10. And negative 6a plus b must equal to 0. So that means b is equal to 6a. Plug that in here. You get a plus 6 times 6 is 36a equal to 10. So a must be 10 over 37. And b must be 6 times this one, so it's 60 over 37. Therefore, the solution you get is the following. After you plug in your a and b back in here, the solution you get is I equal to 10 over 37 cosine 2t plus 60 over 37 sine 2t. Okay. Now, I was just asking for IP, but what if you were asked to find the angle which the current is lagging behind or going before the voltage? What do? You have to make this into square root of 10 squared plus 60 squared over 37 squared times cosine of 2t minus alpha, right? Where alpha is equal to tangent inverse of this over that. Okay? So it's 60 over 37 divided by 10 over 37. Since these are both positive, you don't have to add anything. This is 0. That's the angle by which the current will be lagging. Actually, this will be something positive, so current will be certain degrees ahead of the voltage. So that will be the phase angle.
When alpha is positive, it's leading, and when it's negative,
Yeah.
it's lagging.
If alpha is positive, it will be leading, and if this is negative, it will be lagging. Okay? By the way, this angle here is determined by the sign of this. So if I call this as A and that's B, and depending on the quadrant, if it's in the first or the fourth, you don't add anything. If it's in the second, you add 180. If it's in the third, you subtract 180. By doing this, you can make sure that your angle is always between negative 180 to positive 180 degrees. Okay? So this has to be done.